So we know that graphing a function is super important and gives us a lot of information. It gives us a visual picture of what's happening on a function over the life of a function, from its domain to its range, where the x-intercepts are, which is super important information, and where the maximum or minimum values might be. So we can see by looking that the domain of this function is anywhere from negative infinity on the x-axis to whatever this is. Now the problem is, I need to know whatever this is, and often graphing isn't sufficient and we have to use algebra to find exact values. And that's what we're going to do in this unit. We're going to solve radical functions. Solving a function always means finding the intercepts on the x-axis. So let's go ahead and find the intercepts for this function. Equations involving radicals follow a certain sort of order of their own. When we talk about order of operations, there's a certain sort of order that goes with radicals. And it means that you want to isolate the radical on one side, because then I can use the inverse of a square root, which is squaring, to get rid of the radical symbol altogether. So I'm going to go ahead and add 2 to both sides. Okay, so I've isolated the radical on one side. Now if I square both sides of the equation, the square root squared gets rid of the radical. So if I do that, I lose the radical and I have 100 minus 12x on the right-hand side. Now the left-hand side is different, right? Because I'm going to square this, which means I'm squaring a binomial. So the answer would be, or the square of this binomial would be 4x squared plus 2x times 2 is 4 times another 2 is 8x plus 2 squared is 4. Now notice I didn't write down the step. I didn't put the step in where I have 2x plus 2 squared, which is 2x plus 2 times 2x plus 2, doing my loop work and then combining like terms. I didn't put that step in. This is pre-calculus. You're assumed to know how to square a binomial, and so the expectation is really that you go right to whatever the square is. So we're going to lose our helper steps that come from Algebra 2 and start working directly on our function. If you need to do this still, you should put a little caret that says you're going to go off on the side and do scratch work. Basically what that tells the reader is that this is what you're doing, right? And you just needed some scratch work. It tells us that this is something that you're doing on your own. It's not part of the problem. Okay, let's go on from here. So now that I've isolated or gotten rid of the radical, now I just have a quadratic function to solve, and we know that that means to move everything to one side and set it equal to 0 to solve these. So I'm going to put 4x squared, 8x plus 12x is 20x, and then 4 take away 100 is minus 96, and all of that is equal to 0. Well, first thing I want to do before I factor the quadratic is get rid of any internal or inside integer factors, and I have one, which is a 4. So x squared plus 5x minus 24, and that equals 0. Now factor 4 times, well, this is going to be x, 2 numbers that multiply to give me a negative 24, but add to give me a 5. It's going to be 8 and 3. So, and I need it to be positive, so the 8 is going to be positive, and the 3 is going to be negative. Equals 0. So my two solutions are x equals negative 8, and x equals positive 3. So this is not only have I found the presumed answers, but I've shown you the process by which you should be working on problems like this. This is what this type of problem looks like when somebody else is reviewing your work. Namely, now it's me, but in the future it could be another teacher, it could be a boss, it could be a journal you're reporting findings to. It's always important how you report your work, and this is what a radical solution should look like. Now, because it's a radical, we know that it's possible to get extraneous answers, meaning that you get solutions, but they turn out to not actually be true. One way to kind of find erroneous solutions is to go ahead and set up the domain restrictions that 100 minus 12x is required to be greater than or equal to 0. So that means x is less than or equal to, I subtracted 100 and I divided by a negative 12. So less than or equal to 25 thirds. All right, now my values are integers, so just to be sure, I'm going to convert to a mixed number. Normally we don't want them, but sometimes we need them just to see what we're talking about. So this is 8 and 1/3. So our x values are required to be less than or equal to 8 and 1/3. And both of our values are less than and equal to 8 and 1/3. But that doesn't mean they're solutions. We still have to check. So if I put my first value, negative 8, 2 times negative 8 equals, and we're not sure it equals, 100 minus 12 times negative 8 minus 2. Negative 16 equals 100 minus, well, 100, this is going to be a plus. 12 times 8 is 96. 100 plus is the square root of 196. Minus 2, and this is negative 16 equals, and I'm going to cheat, I've already done this work, it does not equal 12. So we know that this is not a solution. Even though it wasn't eliminated by our excluded values, it is not a solution. Let's look at, and we would have seen that actually by looking at our graph, correct? Our graph, I don't know exactly what the other solution is. I think it's 3. But our graph shows us that clearly there's not a negative value on this graph. Or at least this curve doesn't cross the x-axis at anything negative. So negative 8 would certainly not have been a solution. But we didn't want to have to graph. We wanted to do it algebraically. So now let's check our other value. 2 times 3. I don't know if it equals 100 minus 12 times 3. So remember, when I talk about what something should look like and steps you're allowed to skip, you saw me skip steps here, but you didn't see me skip the substitution step. That must be recorded because I need to be able to see what, or your reader needs to be able to see exactly what you're doing. So this would be 6 equals, well, let's see, 12 times 6 is 64. Nope, 12 times 3, sorry, is 36. 100 take away 36 is 64. Clearly I'm looking at notes. And so 6 equals, well, the square root of 64 is 8, take away 2 equals 6. So this is definitely a solution, and I can say that the intercept here is 3. Now that's the only information I needed. If I had have wanted more information, like what is the value of 4, plug in 4, well, I would have to graph, or I'd have to substitute 4 in. But the information I needed in this solution was only where are the roots, and so that's all I needed. All right, so let's look at one more. It has a special case in it. So we have the square root of x plus 1 equals 1 plus the square root of 2x minus 12. So I have two radicals to get rid of, and squaring both sides is one of my operations, so let's go ahead and do that. And when I do, I have x plus 1 left on the left-hand side, and I have, well, this is just a binomial, right? So I'm going to do my work over here so I don't get any ugliness in my problem. So this is the same thing as 1 plus the square root of 2x minus 12. So that would be 1 squared is 1 plus 1 times this radical times 2. So I have plus 2 times 2x minus 12, and then plus, now I get to square this. So I have 2x minus 12. So when I copy it over here, I've got only prettiness. 2 root 2x minus 12 plus 2x. 1 minus 12 is minus 11. Well, what the heck? That was supposed to get rid of my radical. Well, it does. When you have radicals on two sides and you've got other stuff happening to the radical on one of the sides, it just means you're going to have to go through the process twice. So all I have to do now is isolate this radical by itself and get everything else on the other side. I'm going to move it over here just because I like it there. Okay, so on my other side, I'm going to have the x plus 1, so minus all of this and then divided by 2. So I have a positive x minus 2 is going to give me a negative x. A positive 1 plus 11 is going to give me plus 12 all over the 2 I have to divide by. I can pretty this up at this point, but I don't know. I could leave it or not leave it. Now, I did have the choice of leaving the 2 and squaring both sides to get a 4 and then later dividing and getting a 4. I don't know which one is easier, but at this point I've already done the work, so I'm going to just stop here. Now square both sides again, so I get 2x minus 12 equals, well, I know the denominator squared is going to equal 4. I'm not really sure what this equals. I could kind of do it in my head. That minus throws me off a little bit sometimes, so I'm just going to do minus x, or actually I can switch it and write it as 12 minus x squared, and then do my work over here. So 12 times 12 is 144. 12 times negative x is negative 12x times 2 is negative 24x, and then plus x squared. So my numerator is 144 minus 24x plus x squared. Okay, so my radicals are all gone. I'm just dealing with a quadratic function now. So I just want to solve for, get everything on one side and set it equal to 0. So first I'm going to multiply both sides by 4. So I get 8x minus 12 times 4 is 48 equals 144 minus 24x plus x squared. So now I want to order everything. I've got x squared, and then I'm going to work on this side. I'm going to switch it to this side, but I'm starting on this side, moving everything over. So x squared, holy cow, that's my dog. He's apparently excited about being in a math class. Where was I? X squared, so I've got minus 24x minus 8x. So that's a negative 32x, and then positive 44 plus 48 is plus 192 equals 0. Holy moly, that's a big number. So there are a couple of strategies for finding the your factor values. I'll do one of them. This isn't my favorite, but I think it's a good one to show. So if I take 192 and write it as a product of primes, right, let's get the prime factorization. So 192 divided by 2, what is that? 2 goes into 19 9 times, leaving a 1. It goes into 12 6 times, so 96. And then divide this by 2, I get 45 plus 3 is 48. Divide this by 2, I get 24. Divide this by 2, I get 12. Divide this by 2, I get 6. I know it seems tedious, but divide this by 2 and I get 3. And so what we're looking for is combinations of these that will total 32 if I added those. So let's see. 2 times 2 times 2 is 8. So if I cut it off here, 8, and 2 times 2 times 2 times 3 is 24. Are 8 and 24 oh man, I picked the right one, didn't I? 8 plus 24 equals 32. So right off the bat I picked the right one. I might not have, but that's a strategy that you can use. So I know that I have x and 24, and then I have x and 8 equals 0. So this is positive, so they both have to be negative, or both positive. This is negative, so there we go. All right, so my choices are, or my solutions, my presumed solutions are x equals 24 and x equals 8, and I can't use these solutions or declare them to be so until I check in the original problem. Now you're expected to do that on your assignments, but I'm not going to make you watch me do it again, because that's just pluggy chuggy math. I'm going to tell you that 24 turns out not to be a solution, and so the only solution to this problem is 8.